All right, a few announcements and then we'll get to notes. Um, Kind of the schedule for the week. We'll do 3.8 today. We'll do 3.9 and a review assignment on Thursday. And then next week you'll have your unit test. And so what I am going to do, or what I'm going to propose, is there's no live Zoom class next week, and it's just Monday and Tuesday. And after that, we're on winter break. Um, but if you would like, if you have any questions on the review, if you would like to ask questions about the test before you take it, I will be available. Just shoot me a message and I can certainly do that. Um, but we're not going to have a regularly scheduled class meeting next Monday. So um, the one time you get to see me before winter break. So, make the most of it. All right. So, chapter 3, lesson 8 is about rates of change in natural and social sciences. And actually, the one um, application, the one situation that the College Board has used on the AP exams is the motion of a particle. And so that's where we're going to um, kind of focus our time today. So a problem might look something like this. Whoops. One page at a time. There we go. The position function, S, which is just a function of time, is given as t cubed minus 6t squared plus 9t. And we're going to use that function and answer a bunch of questions. We're going to find the velocity at time t. We're going to find the time when the particle is at rest. We're going to find the interval when the particle is moving forward. We're going to find the total distance the particle travels in the first 5 seconds. We will find the acceleration at time t. And the last question, when is the particle speeding up and when is the particle slowing down, on what intervals? Very typical, you might see something like that on the AP exam. Now, if you haven't written all the questions down, that's okay. I've got them written down throughout the notes. So we are going to get started by finding the velocity. And to find the velocity, I've already forgotten what our function is. All right. So velocity at any time t is simply the derivative of the position function. So if I take my derivative, what is the derivative of t cubed?
3t squared.
There we go. I know it's Monday. I didn't want to get up and come to work today, so I can't blame you guys for maybe being a little bit sluggish. I'm going to be sluggish all day today. All right, and then the derivative of minus 6t squared.
12t.
Yep. And the derivative of 9t.
9.
There we go. That's the velocity at any time t. When is the particle at rest? So the particle would be at rest when the velocity is 0. So our velocity function set equal to 0, and then we're going to solve for t. And in this case, probably easiest, factor out that 3. And then flashbacks to algebra, factoring, finding two numbers that multiply to 3 and add to -4. And if we set each of those factors equal to 0, we get t equals 3 and t equals 1. Those are the times when our particle is at rest. Questions so far? All right. When is the particle moving forward? So the assumption here is this particle is moving forward and backward. Sometimes in the situation, the particle will move up or down, and sometimes it'll be left or right. Forward, right, and up will all have a similar characteristic. So it's moving forward in this case, or again, up or right when the velocity is positive. So in the previous problem, we found that the velocity could be factored into that expression. And so what I'm going to do to determine when the particle is moving forward, I'm going to plot those values on a number line. Because I know that at 1, the particle is not moving forward or backward, it's at rest. And at 3, it's at rest. And the only way for it to change from moving forward to moving backward is it has to rest for an instant. And that's because the velocity function is continuous. So what I would do is pick some values on each interval. So in general, when we're talking about motion, we start at 0 and move from there. Generally don't consider negative time. So if I pick a value between 0 and 1, like maybe a half, and plug it in for t into the velocity function, that will tell me if at 1/2 the particle is moving forward or backward. And so at 1/2, well, 3 is positive. That's always going to be positive. If I plug 1/2 into the t minus 3, I get 1/2 minus 3, which is negative. I don't really care what the value is. I just want to know if it's positive or negative. And if I plug 1/2 in to the factor t minus 1, I get something that's negative. And if I multiply a positive number by a negative number by another negative number, my answer is positive. So that means every value for the velocity between 0 and 1 will be positive. So between time of 0 to time of 1, our particle is moving forward. Now we're going to check the next interval and find a value, pick a value between 1 and 3. I know most of you are thinking right now, well, let's just use E, Mr. Gingrich. I would probably use 2. How many of you were thinking E by show of hands? Okay. Again, same thing. We're going to plug 2 in and see what sign we get for each factor. The 3 out front is always positive. 2 minus 3, negative. 2 minus 1, positive. And so if I multiply a positive by a negative by a positive, my answer is negative. And that last interval, pick a number greater than 3. I'm going to resist the urge to choose pi. I'll use 4. Again, the 3 out front is always positive. 4 minus 3 is positive. 4 minus 1 is positive. So in this case, the particle is moving forward on the interval from 0 to 1, also on the interval from 3 to infinity. Any questions there? All right. Find find the total distance traveled in the first 5 seconds. Now be careful. This is not saying take the position at 5 seconds minus the position at 0 seconds. That is net distance. And not what we're being asked here. Because the particle is moving forward from 0 to 1, we can just take that distance. Then it moves backward. So what we're going to do is take the absolute value of the distance that it travels from 3 to 1. And then it moves forward again. So we'll take the positive distance. We don't need the absolute value. That distance will be positive. And we're going to add those together. So in this case, we're going back to the position function, t cubed minus 6t squared plus 9t. And one way to do this is just use your calculator. So if I put my position function in y1, and make sure my table is set 0 counting by ones, that's good. So my position at time of 0 is 0, and at time of 1 is 4. So this would be 4 minus 0. I know at 1, I get a 4 here. And if I look for the position at time t equals 3, it's back at 0. And at t equals 5, it's at position 20. Add those 3 distances together, and it's traveled a total of 28 units, whatever that unit happens to be. We weren't given units in this problem for the distances. Usually it's meters, but it could be feet, it could be miles. A couple different choices there. All right. So far, so good. Continuing on. Find the acceleration at time t. Well, acceleration is the second derivative of position or the first derivative of velocity. So we know what our velocity function was. So acceleration is just going to be our derivative. And I should be a little more precise here. All right, so we take the derivative of 3t squared.
6t.
6t. And the derivative of minus 12t.
12 minus 12.
Here we go, perfect. That's our acceleration at any time t. You might be asked, Olga, what's the acceleration when t equals 3? Pretty easy now that we know at any time, we can just plug values in to calculate then acceleration. The last thing you'll be asked is, when is the particle speeding up and when is it slowing down? So in general, a particle is speeding up when velocity and acceleration try this again. Have the same sign. Slowing down when velocity and acceleration have opposite signs. So we know what our velocity function is. We just found our acceleration function. And we actually know the signs for velocity like that. And we could do a similar thing for acceleration. when does acceleration change sign? At what value of t will our acceleration change signs? That's when it's 0. So in this case, t would be 2. And so I'm going to mark that here. And so just like I did with velocity, I'm going to do the same thing with acceleration. Pick a value on the interval from 0 to 2. Like 1. If I plug 1 in for my acceleration, I get a value that is negative. Pick a value greater than 2, like 3. If I plug 3 in, I get a value that is positive. So if I use that information, I'm going to draw some dashed lines through here. So from 0 to 1, velocity is positive, acceleration is negative. So it's not speeding up. From 1 to 2, velocity is negative, acceleration is negative. There it is speeding up. So that would be one interval where it's speeding up. From 2 to 3, velocity is negative, acceleration is positive, not speeding up. From 3 on, they're both positive. And for slowing down, signs are opposite from 0 to 1. And signs are opposite from 2 to 3. Questions on that one? So for your homework, I know huge assignment. On 237, doing problems 1, 2, and 3. Skipping F and skipping H. F and H are asking you to draw diagrams and graphs, and I just don't think we need to do that. So I'm allowing you to not do that. I will say for number 3, make sure if you're using your calculator that you are in radian mode, because it does have a trig function for position.